Hey, what's up guys, my name is Cherno, I'm still on holiday at the moment. This time I'm in Sweden. And then this email popped up in my inbox. Please tear my code apart, I just couldn't resist, you know. So we're gonna take a look at Cameron Otten, who wrote Hey Cherno. So I made this thing a while back in C++, was intended really to be a game more than an engine per se. I got a little stuck, but recently went back and fixed a couple things. Alright guys, we possibly might need to bounce.
Where are you?
Alright, so joining me for this code review is Peter, who works at Studio Cherno. He's a Hazel engineer. The camera doesn't seem to like to focus on him because we all know that this is my channel.
Yep, definitely.
Okay, so we've got a C++ thing. It's a game more than an engine. Recently starting to think of my career and would like to actually get into the industry and use this code as a good portfolio. So this is going to be like, he wants this to be a portfolio, right? And he wants me to tear it apart. So we're not going to be, we're going to be a bit roasty. We're going to be a bit harsh here. We're going to be a bit realistic. Okay, so object-oriented programming, he understands and sees its strengths and weaknesses, but ultimately prefers to have global functions. I think that's probably a good idea generally. I don't like it when people constrain themselves to like a particular code style, right? Like it's good when you use a mix of styles.
Yeah, you should use like whatever fits.
Especially if you're using a language like C++ that obviously doesn't like constrain you into specifically being object-oriented, you know, like something like Java. It's, you know, it's often better to pick the right tool for the job, and I personally don't think that any particular programming paradigm is necessarily 100% suited and perfect for something like that. What do you think?
Yeah, like you should definitely just use whatever paradigm fits the best for the task.
Okay, so please look in depth at this code. There's a lot of neat stuff as well as some hacky stuff, but don't go easy on me. Look at it as if you were hiring someone and we're looking at their competency as a programmer. And yes, main is a mess, I know. Okay, so it's always interesting to me when people send in code with like 100 disclaimers, because like, you know, when you read the text, look at it as if you were hiring someone and we're looking at their competency as a programmer, but then in the same sentence, actually no, I mean there's a full stop here, so maybe not the same sentence, but yes, main is a mess, I know. It's like, maybe fix it up first, and then I'll look at it as if I was hiring someone. Okay, so this is the actual project itself, by the way. It's called Think. It's got some nice looking shadows. We took a quick look at that. It's basically Hazel's shadow system.
Yeah.
But implemented not as well because it doesn't look as good. But it's PCSS. So we've got some debug rendering, and I guess the physics is custom, right?
Yeah, it's, from what I could tell, it's pretty much completely custom. And I'm not sure if all of these boxes are individual colliders. I highly doubt it, but the debug rendering would indicate that, in which case they most likely use some sort of broad face algorithm.
I think they might be, because their cell, remember the cell kind of, and the way that we should probably show what the levels look like when we had a quick browse.
Yeah.
But yeah, I think this is basically kind of like, they've used like a tile map setup. So yeah, so like this is what the levels look like. So I guess they look like nodes. There's a free camera as well. I mean, yeah, it looks like just like a little kind of physics demo / level layout thing.
Although
the mouse isn't quite captured.
Yeah. The mouse is hidden, not locked. But yeah, here we can actually see that it seems to be using some sort of velocity expanded bounding box for doing basically a broad face collision check. Which, you know, is clever, especially when you have a lot of colliders. So, like, I'd say physics-wise, in terms of the actual functionality of it, it's not bad. Like, it definitely seems to be working, and it's running pretty well. Although some of the collision checks aren't quite accurate on certain corners. It's like you can manage to get into the actual geometry there.
Alright, so I don't want this to be another video about the build system. Peter and I looked at the build system, and
I don't like it.
Yeah. It's just a batch file like this. I'd had echo off at the start. We had to disable that because we had to debug the build scripts.
And disabling that somehow fixed it.
Yes.
So, great.
Yeah, like, I mean, my suggestion, obviously, is, like, to use something like CMake or pre-make. I mean, I don't know why I said CMake.
Yeah,
to be
preferably
honest.
pre-make.
You should use pre-make. But you know, using a build system is a lot better than trying to write a script like this. Obviously, this only works on Windows anyway, and it only uses Visual Studio, which also begs the question: why is this not just a Visual Studio solution?
Yeah, and it was hard coded to Visual Studio 2019.
Yeah.
Which means you
Oh yeah, that's right. We also had to change that.
Yeah.
Anyway, we're not going to talk about the build system in this video. We're just going to move on to the code, which again does not have a Visual Studio solution. So we just open up the folder in Visual Studio, and here we are in the main file. All right, so here we are in the main function. Peter, I want you to look at this and tell me what you see. If there's anything that like jumps out at you, and if you were hiring someone for Studio Cherno, what would you say?
So I would say that there's a lot of if-defs for debugging. And I will say that the code is not the most readable, just because there's, like, a lot of this I would have grouped into better kind of sections, either by using like a block scope or by simply moving them into separate functions.
Yeah, it's weird that this is all in the main function.
Yeah.
Like, I mean, he did say that main is kind of messy and stuff, but this seems like, let's take a look at this quickly. Like, how much stuff is in here?
I think it's like 700.
700 lines of code, but it's also like, it's the entire application.
Yeah.
Like everything from initializing SDL to loading meshes and assets and shaders.
Dispatching draw calls is in there as well.
Yeah, debug rendering OpenGL code. Like,
Yeah.
I mean, he did say that it's kind of more of a. By the way, apparently they don't make good chairs in Sweden.
I mean, it's a 10-year-old chair.
I think we need to go to IKEA. Now, if you're enjoying this roasting and you want me to roast your code, review your code, my mistake. Send it into chernoreview@gmail.com. There'll be some instructions in the description below. But if you're not quite ready for the roasting, if you're still a beginner, then there's an excellent free way that you can learn computer science online with the sponsor of today's video, Brilliant.org. Brilliant.org is an amazing website filled with lots and lots of courses on various STEM topics. The thing that really sets them apart, in my opinion, is their kind of visual and interactive and engaging approach to learning. They've got some excellent kind of beginner level computer science courses that will really kind of hold your hand and gently introduce you to being able to think like a programmer. And then I really highly recommend their math courses. Everything from like the everyday math course, which is excellent for beginners, through to things like algebra, linear algebra, calculus, stuff that is honestly really useful to know if you're programming things like this game engine. Now, as I mentioned, visual and interactive. They've got like these widgets you can play with in their bite-sized lessons. Taking this stuff in visually, really, really important, and they'll also quiz you to make sure that you're paying attention, retaining this information, and learning. Now, the best thing about Brilliant is that they have a 30-day free trial. You can just browse their entire platform, see what courses they have available, try them, see if it works for you, for free. Just go to brilliant.org/thecherno, and if you do go on to like it, they've been nice enough to offer the first 200 subscribers 20% off an annual membership. Huge thank you to brilliant.org, as always, for sponsoring this video. I've said this before, by the way, in other code reviews, and it's always really difficult to not repeat myself, but I think it's really, really important to have an application like file and class, so that you can just shove in all of the initialization and de-initialization kind of code into one place, so that you're not polluting like the main function. There's also a lot of renderer initialization related stuff, like that should be in the renderer class, There's so many different engine systems that I'm seeing here that really shouldn't be just in one file and in one place like this. They should just be separated out.
I can also kind of see why people do things like this, because I think a lot of it comes from them wanting to just get it up and running and then improving it afterwards. But I think there's a limit to that, because like fast iteration is good, but you should still not just dump everything into a single place and keep it there.
Yeah. No, I think that the other thing is like possibly when people don't know what the architecture should be yet, because they haven't written stuff, like if you've built an engine before and you know exactly like, okay, I need a renderer, I need an application, like a file or whatever, I need like something to, hold like game state, like a scene, the concept of a scene system. Like if you know all of that, then that's great. You can just be like, all right, well, I'm not gonna waste time. I know I need this file, this, like, you could almost just make like all the classes up front, leave them empty, and then fill them in as you go because you know how it goes.
Yeah, exactly.
But if you're like doing this for the first time, you might not know enough about it to start making structural decisions.
Yeah.
And so you might just kind of plop everything all into one place and then be like, okay, I'm gonna do, because I do this as well. Like if like let's just say I'm implementing grass rendering or something that like I've never done before. I'm gonna sit down and I'm gonna learn about grass today.
Yeah.
Like it would be a waste of time and also unnecessarily difficult for me to go through everything and just be like, okay, I'm gonna make this grass generator class. I'm gonna make like this grass cache class or whatever. I'm gonna have to make like some renderer functions that are going to, I don't know, build up some storage buffers filled with grass blades or whatever, right? Like it doesn't make sense to me because I've never done it before.
Yeah.
So it might make more sense for me to just be like, here's a function called do grass, and I'm gonna put everything, absolutely everything there, and then I'm gonna go back through it, like once it works, because again, step one, I feel, is always just make it work.
Definitely.
Right? Like just make it work, and then once you've made it work, you can refactor it, you can iterate over it a few times to make it more flexible and more kind of, maybe add more features and more extendable as well in the future.
Yeah. I think that's, generally speaking, a good philosophy to have. It's like, there's no real point in actually architecting this really complex system if you don't actually have anything working yet, because you don't necessarily know what it's going to end up looking like.
Yeah.
You don't know exactly what you want it to do, essentially. And I think if you have something already working, you can then work backwards from there to some sort of API that you actually like.
Yeah, I think another thing is like recognizing potential, like almost like patterns in code. Like, the code we're looking at right now on the screen, kind of coincidentally, because we just scrolled to a random place, is like, creating these samplers for textures in OpenGL. And like, the thing is, you can kind of see the parts here that are clearly the same, right? So like these sample parameters are identical. Yeah. They're just setting the magnification and minification filters to be linear. Then we need to set the border color, and they're both being set to white here.
Yeah.
Then we're doing the wrapping and the compare modes as well. Like all of this stuff, like this is a really good kind of opportunity to take that and be like, all right, how can I condense this code by potentially making like a texture class, which, I mean, it looks like there is one. Oh, but it's just a struct. So see, this is actually really interesting, because this is kind of where it's shying away from object-oriented programming and going a little bit more C style, because what you do there is you have structures of data, right? So we just have a struct that is just kind of a pod type, plain old data type. There's no functions in here. There's no like deep kind of pointers to other blocks of memory.
Yeah.
There's just 4 integers of like data. And then the functions around that, like we have a function like create texture, which is just a global function, which will run that. So this is a very C style kind of approach, right?
Yeah.
But I would argue that like in this case, I feel like it's not as good. And, a lot of this is obviously personal preference. So like, here's an example from Hazel. We're creating just a white texture, right? And this white texture is just something that the renderer stores, because whenever you need like, basically to kind of not have a texture set or something that you can multiply by to just get like, because white is 1. So if you multiply by a white texture, you won't change the original data. And this is like all of the code, that does, I guess, all of this.
Yeah. Basically.
Right? And it's way more flexible as well. Because, I mean, well, for one, this doesn't even include, the data's here, okay. Oh, right, so the white is the border. Yeah. So we're not actually setting any data here for the shadow map, I guess, which is fine. So this is interesting because it's kind of like, it's also got that approach, where we're, like, this is kind of a pod data struct, right? This is the actual, like, specification for that texture. So what kind of texture would you like to create? By the way, what do you guys think of Peter's color style? It's a little bit different than mine. I'm trying to get used to it.
Partially ripped from JetBrains.
Disgusting.
Did tweet the things I didn't like.
Which was all, like, most of it.
Yeah, pretty much.
So you can see that like this basically just tells you how to create that particular object, right? It's just the specification for it. We can set it up, we can share it. It's very easy to copy it as well. Like if you want like a spec that does like 90% of the stuff similar to another spec, then you can just go ahead and obviously copy it, just like a normal object copy, right? But then this is the line of code that creates the texture, and you can see it just takes in the spec, which tells it what kind of texture it is. So it's a 1x1 RGBA texture. And then we take in the actual texture data that it will automatically kind of upload to the GPU. And then internally, obviously, that will create like a Vulkan texture and it's ready to go and it's stored inside this object. So what I like about that is that it's incredibly simple. Like from an API point of view, you know, as a human kind of reading this code, you can immediately just be like, what's going on here? Oh, well, I'm creating a 1x1 RGBA texture with this data and it's ready to use. Like, I don't think this could be more simple. At least not without sacrificing like the flexibility of what's possible with this actual API.
Yeah.
By the way, guys, I'm trying to lean back so that we're both in focus because
autofocus.
Yeah, so don't mind us being blurry.
Yeah, but yeah, no, like even having like a specification struct for types like the application, like it to me it just makes it nicer because you don't have 20 different parameters to a constructor.
Yeah. Well, that's the thing, like, you know, people don't like huge functions or huge constructors with lots and lots of parameters. But then, like, you know, what happens if what you're writing is complex?
Yeah.
You know, that's the thing. Like, I feel like a lot of programmers who are maybe more like beginners or inexperienced, like, you know, they'll always be like, they'll look at code and they'll maybe feel overwhelmed by it and they'll just be like, no, this sucks. Like, I don't understand this, or this is like, why are you overcomplicating things? Why are you making it like this? But the thing is, there's overcomplicating stuff and over-engineering stuff, that's definitely a thing. Like, that's a big thing, right? But there's a difference between overcomplicating something, right, and just having a piece of code that actually is complex because it just does a lot of stuff.
Yeah.
Like, we were talking about this last night. Like, game engines, like, physically do a lot of things.
Yeah.
That's why the files are so big. That's why there's so much stuff. It's not that the actual code, if you break it down piece by piece, like at least with Hazel, like I don't think, of course there are some complicated stuff maybe, you know, for some of like the shaders and graphics passes we might do that might require a little bit of research to understand. But generally speaking, the C++ code, I don't think it's that complex.
Yeah, no.
It's just there's physically a lot of it. And
Yeah.
I compared it to like, you know, a short story versus like an epic, right? Like an epic novel. Like that, obviously, like two different things. Like they're not necessarily going to be written in like, you know, one is like, I mean, shorter things generally might be like, you know, like a children's book is obviously generally not 1,000 pages long, but it's not necessarily like more difficult to read something that's longer because it entirely depends on the language that is used and the style that it's written in. And so I think with code as well, you can obviously have something that is, you know, very, very complicated and long, or you can have something that is long, but it's written really cleanly and it's easy to understand. But, you know, a game engine just has a lot of things that it physically has to do, and there's no way around that.
Yeah, and like I think that becomes obvious when you look at some of Hazel's system. It's just like, sure, you know, we might have a file that's 5,000 lines of code, but when you actually break it apart, it's not overly complicated. It's just there's a lot of code needed to get the job done. So yeah, no, I definitely say, you know, when it comes to code, there's a huge difference between complex code and large code.
Okay, so the other thing that kind of Peter mentioned a bit earlier was all of this debug code, right? So again, and it's funny how, like, I feel like most of this code review could really just take place in this file, because even though there are other files here, like, you know, a lot of it seems to be in main.
Yeah.
And I mean, these files are huge, which a lot of people would look down on, but I don't. I think that having large files is totally okay.
Yeah.
As long as it makes sense, like, meaning that, like, you know, all of your stuff is kind of relevant. Like, this is another great example of why this main function is so bad. There's so many reasons, but one of it is because it's not just doing one thing. It's not just doing, like, a couple things. It's literally, like, everything from, you know, setting up this game state and game memory thing, which, by the way, we probably should take a look at a little bit later as well, just because this is kind of unique.
Yeah. Game state actually had, like, an application.
Oh, yeah. But it sees destructive data.
Yeah.
That's the thing, like, which again, it's fine. Like, I don't agree with this. I would make it more object-oriented, but it's fine to have it this way if that's who you are, as long as you still make an application.cpp file that contains those related global functions. You know? Like, you don't want to just put everything here And I mean, the stuff here isn't even in a function. It's in the main function.
Yeah.
You know, so all of this is just kind of floating around here. But again, like with the main function specifically, it's just because there's everything from like, you know, game state, game memory initialization, those kind of systems, to like SDL and creating a window, to initializing OpenGL, to loading data, to, you know, obviously running the game loop, all of that stuff.
Yeah. It's like data-oriented programming is perfectly fine, and it's, you know, you should be using data-oriented programming at times. It's when you have data-oriented programming but there's no structure to it that it becomes an issue for me. Because it's like, there's nothing wrong with, you know, working in C, for an example. Just because it doesn't have classes and constructors, it's still fine because you can still emulate that. And people have been doing that for decades. It's just when you have like data-oriented programming in terms of the actual data structures, but then everything else just dumped into random places, that's when it becomes an issue for me.
I'm not sure if this is data-oriented kind of programming. Like, well, at least the way I define data-oriented programming is it's specifically designed in a way, like where you're paying attention, obviously, to like the memory layout, to the cache coherency, to all of that stuff, right? Just by what he's doing, I mean, I'd probably call this more of like just procedural kind of programming, where it's like, you know, you just have your structures which contain data, and then you just have functions which run stuff on that data.
There's just everywhere, like in the entire project, really. It's not just like in the main function. There's a lot.
The main function is like half the project.
I mean, yeah. There's just a lot of these if-def debugs, which actually like strip a lot of the code from release builds. And like, obviously you have to strip stuff from release builds because you're gonna have code that, you know, shouldn't run in release mode because it's just there for debugability.
Which, actually, let me stop you right there. This is also why I hate this idea of debug and release. Because there has to be, like in my mind, there has to be 3 configurations.
Yeah.
There has to be, that's why Hazel has debug, release, and dist.
Yeah.
Because like the problem is debug implies no optimization, and like debug to me really means like breakpoint IDE kind of debugging.
Yeah.
You know, and for that you obviously can't really optimize code, can't really inline code, at least not as well. You can't go too crazy with the optimization, otherwise you won't retain that original code structure that lets you kind of inspect every variable. You know, you'll strip stuff out that might not be used, but that you wanted to debug because you're in the middle of working on something, you know?
Yeah.
Like debugging, that's what debug is, right? But the problem is, if you just want to have debug rendering, which like, if we look at this code as well, like, you know, debug shader, like this stuff is drawing debug graphics. Like you absolutely want that to run not only in debug, because debug, first of all, might be too slow.
Yeah.
Like that's another thing, right? Like because debug has no optimization, like, yeah, it's great for breakpoint debugging, but it's not good for debugging within the tools that you've built into the application.
Yeah.
Like, if a game engine editor ran in debug mode, it would be very, very slow.
Yeah.
Like, it could be like 10 FPS, right? And it's unusable. So basically, you definitely want to like be able to run everything in release and still have all of your debug tools available to you. So that's, I think the weirdest thing to me straight away, apart from, again, these if-defs are just kind of make everything dirty, but like, it's just the fact that like, you know, you're stripping this out of release builds.
Yeah.
Like this stuff is really useful.
Yeah.
It's kind of like, I looked at that code, I did code review of a project where they did, I think it was like a ray tracer, and then they had debug single-threaded and release multi-threaded.
Yeah, I saw
and
that.
it's like, that's 2 different code, like that's entirely 2 different, like, that shouldn't be, you know, if you want to have multi-threaded or single-threaded and you absolutely want that to be compile time, make a separate macro or like a separate kind of define that's like multi-threaded or not. So that you can then be like, okay, I want single-threaded debug mode or multi-threaded debug mode, because you might want to be debugging your multi-threaded code.
Yeah.
You know, like it's weird when people kind of tie stuff, you know, to debug, even though I guess in a way that makes sense. I mean, it's possible though, like we didn't really look at this though. It's possible that we're just wrong about this. Like,
I mean,
this might not be the debug configuration. Like, is this defined anywhere?
It might be in the build script. That's just, yeah. So it's defined
So
as...
debug is on, and this is what debug. This is a debug build.
Yeah.
They don't have release builds
No.
though. So interestingly, they don't seem to have, in the build script, there doesn't seem to be a release build. They're just like, I'm just looking at debug build finished, debug build unsuccessful, like everything's a debug build.
Yeah.
So there's no concept of a release configuration at all. I don't know, it's weird. It's like, it's so annoying to then go through and be like, let me add another one of these for release. Like just use either Visual Studio with Visual Studio project files and a solution and everything, or use like Premake, or even like CMake would be better than this, to be completely honest. And that's saying a lot.
Honestly,
from me.
probably even using Make on Windows would be better than that.
Make on Windows.
Which, that requires a whole rabbit hole.
That requires reading like a 1,000-page book, probably.
Probably. But yeah, like, some of that stuff that's been put into like these if-defs should not be probably done outside of a very explicit debug mode. Some of it should be done in debug and release, but not a distribution.
Yeah.
And some of it probably shouldn't even exist.
I guess my main point here would be that you want to run your code, you want to build your code with optimization on, fast mode on, but retaining your debug tools.
Yeah.
Right?
Definitely.
That needs to be a configuration, because that is the most, like, how often do I run Hazel in debug?
Yeah.
Like, very, very rarely. Only if I'm really having to step through and debug stuff.
Yeah.
Usually for higher level stuff, it's always run in release mode, and I just use the tools that I've built into Hazel.
Yeah.
But then
like,
distribution is for, like, I'm shipping my game, so yeah, absolutely strip all the debug code.
Yeah. Like, I spent quite a bit of time debugging Hazel in proper debug mode for, like, physics and C# scripting and all of that, where it requires me to step through each line and have all of the info that I can get from it. And that's painful. And, I can't imagine doing that in a even more complex engine. A lot of projects, and I think it's a default in CMake, they'd call it run with debug.
Yeah.
Where you have some optimizations on, and you have some symbols on, but not all of them. And then there might be some other options like a debug renderer, so you can actually visualize the data itself.
Yeah. The only, in Hazel, like, debug and release, the only real difference is that, it is the optimization, really.
Yeah.
It's just optimization, but then release will add stuff like inlining and, actual just code optimization on, and, faster floating point precision, that kind of stuff. But, dist is the only config that actually strips debug symbols.
Yeah.
Debug symbols are very present in release still, because that's still an internal build as far as we're concerned. Dist is the only build that gets distributed.
Yeah.
And so, of course, we want to strip all, the function names and all the symbols.
Yeah.
From that, the debug information. But I guess my point of view is that if it's still internal, then, why remove stuff that helps debugging? Internal should mean safe, meaning that I'm not worried about being hacked from within my own company, hopefully. So, it's fine that we, retain all that stuff, obviously.
Yeah, because, here we have, I'm not sure what screen space vertex does, but, presumably, there's some, physics collision debug rendering going on. And having that in release mode is incredibly useful, especially considering, physics on its own can be quite heavy, and you really want to be able to debug the information accurately. And you can't do that if each physics tick takes, 25 milliseconds. So these kinds of things probably should have just been a runtime boolean that you can toggle on and off.
The other big thing about debug code as well, the whole if-def debug, because that comes up a lot. If we just go through this file, there's 7 or 8 times. So the thing is, obviously that's polluting the code, but also when you're reading stuff like this, it's really quite annoying to stumble upon stuff that is purely for debug, and then obviously you have to scroll past that and kind of keep going.
Yeah.
Right? I feel like because debug code like this is clearly supposed to be kind of circumstantial, it's only on in certain configurations, to me, it's kind of like an optional module. You can compile this with extra debugging stuff kind of present.
Yeah.
And so since it's an optional module, it should act like one. It should be separated out into a separate file, ideally, that is just okay, this is I don't know what this is, some kind of debug graphics stuff. So make a file called debug graphics, you have your debug graphics header, you have your CPP file. You can conditionally include that file for compilation only if you want debugging kind of enabled. And so what you're kind of doing there is you're separating it from the mainline code and you're making it non-intrusive anymore so that it doesn't kind of inject itself into there. And it would only be kind of used if it's actually kind of present. And I think a really good kind of comparison to what we have in Hazel is we have, the scene renderer, and then we have something called the scene renderer panel. And the scene renderer panel has an on-IMGUI render function that is only present in Hazelnut, which is our editor. And you can see that there's a lot of IMGUI, there's a lot of UI stuff here. So what this does is it just gives you an entire panel inside the game engine editor that you can use to control the graphics settings, access kind of, graphics debugging tools and stuff like that are relevant to the scene renderer, which is what we use to render scenes in Hazel. And you can see that, again, it is a completely separate file, and we can just be like, you know what, this file, not compiled for distribution. But in the past, it used to be inside the scene renderer file. And that was annoying because, and this is a huge file, but that was annoying because obviously if it's inside this file, then we'd either have to use macros, or kind of ifdefs to strip that out, and it kind of makes this file even longer and not so much relevant because, the scene renderer, it's supposed to render scenes. The ideal thing for that would be, it contains only the code necessary to render a scene, and then extra stuff that is only relevant to the game engine's editor can either be only in the kind of editor module, so we can only have that in Hazelnut, for example, or if we still want it present for debug or release builds in the game runtime, it could also still be in the common Hazel library. But the point is that it's not kind of a requirement of the scene renderer class to necessarily include debug stuff. You're kind of drawing that out and you're making that an optional extra addition that is not intrusive at all to this kind of primary code base. And to me, that's also a really important thing that you could do here. You could kind of bring that out into a debug renderer that is only present in whatever configuration you want, and then set up your build system to just not compile those CPP files in certain configs. And that would just be a lot cleaner.
Yeah, I think another example of that would be in physics. There is, sphere collision check, I believe it was. We have this if.debug, which first of all has a runtime check as well, which, is fine. But it seems to submit actual geometry information for rendering the debug information for this collision check, which I can see why they might put it here initially while they're writing the function so they can test everything. But for actual, in a proper project, I would probably have put this as a thing in the debug renderer, and it would have some sort of internal state as to whether or not it should render the debug information for the physics. And I think we have that in Hazel as well, although that might be in scene renderer. No, actually, I think this is one of the things in Hazel that I don't quite like. Yeah, so in Hazel, it's actually in the scene, which probably should be in the scene renderer, but it's still, it's not part of the actual collision check. Yeah. So in my opinion, it shouldn't necessarily be right here.
It's weird as well because one thing I noticed is the debug memory is not part of this, and I feel like the reason why it's not part of this is because see, it's a required parameter for this function, right? So sphere collision check absolutely has to take in debug memory, which may or may not be used, I guess, based on if this macro is on, if this define is on.
Yeah.
So that's a really good example of why this stuff needs to be separated. You should just have your sphere collision check, which does just the actual collision check that it's supposed to do, just the math really for that. Yeah. And then an entirely separate function in the debug renderer that could be used to visualize that. And again, there's no reason why, if this stuff is actually doing, what does this need? It needs position and velocity and stuff, and maybe this stuff, its position and velocity are just kind of passed in anyway, so they're not calculated using this. But even if they were dependent on this code, you can just either copy and paste this code or separate this part into a different function, whatever you want. But the point is there's nothing wrong with potentially even duplicating this code just for the debug rendering if it means that debug rendering is completely separate from the mainline kind of implementation. Because again, I guess my point is it should be kind of like water and oil, right?
Yeah.
You have your water and then the oil sits on top and it's completely separate, it's completely clean. When it starts being mixed together and you just have debug stuff and debug rendering intertwined with your real code, like that just kind of creates a huge mess, unless you're maybe temporarily doing it while you're writing this function itself.
Yeah, doing it temporarily while you're writing it can be really useful. But once you're done with the function and you know that it's, well, you know, it works for now. Like, you should move this out to a place where it doesn't interfere with the purpose of this particular function, which is to check for a collision. Its purpose isn't to do rendering. This shouldn't, in my opinion, shouldn't be aware of rendering at all. It should just be practically pure math.
Yeah. All right, last thing we kind of wanted to touch on is at the very beginning of this main function, we have this concept of game memory, and we call game memory.allocate, right? So what this seems to be is a struct of memory blocks, and like, you know, here you're using a function, so it's clearly not like strictly, I guess, C style, where it's like all of the structs that you ever use and all the classes / structs you ever use are just POD types, like they're not. But anyway, this has a bunch of memory blocks, and memory blocks are up here. They seem to just be a pointer to a block of memory, which you can potentially request, and then the allocate function will just do a bunch of math to calculate the total allocation size in bytes for all of these different engine systems, and then you'll allocate that basically into a single block of memory, and then kind of just segregate the blocks so that you have a pointer to each category, you know, within that one big memory allocation, which is a very interesting concept. Like, I usually would be on board with something like this because it does result in just a faster program. Because if you pre-allocate everything, first of all, you have a nice big block of memory. Second of all, it's all contiguous.
Yeah.
You know, all the allocations are kind of free within that, right? Because all you're doing is just moving pointers. You're not actually doing any memory allocation. And again, it's all kind of close together physically.
Yeah. It's like you've almost allocated a custom stack at that point.
Exactly, yeah. So it's good. But what I don't like about it is how difficult it makes your life, you know, when you're using this system. Because first of all, again, you need to make sure that you have all of these defined set up, right? Like, I'm going to have, you know, how many is this even? There's 10 million, 1 million, 10 million, I think, right? By the way, in C++, you can do this, which is super useful. So yeah, you have to be like, 10 million verts, which first of all could potentially be a huge waste of memory, right? Because you don't know how much you need. But also, if you do happen to exceed that, it'll crash, which is, you know, an issue we currently have with Hazel's 2D renderer because I did the same thing. So I'm guilty of doing stuff like this as well, and it sucks. Like, I've been through this. I don't like it. So this is kind of like at that awkward stage, you know, in life, where you're like, let's just say halfway between child and adult, and you just don't know what you're doing, and because this is halfway between just using C++ as memory allocation tools, which are great, like in terms of ease of use. I want memory. Let me just run new, and that's it. I'll get my memory done, sorted. Is it the most efficient runtime? No. But it's definitely the easiest if you're the programmer, right? Yeah. And the other side of the spectrum is like an actual like potential arena allocator or whatever per system or whatever, which would speed up the program potentially significantly, right? And just be like a more efficient way to handle like the memory needs that your engine or application might have. But this is in that awkward stage in between, where like it's not easy, it's not resizable, it's not adjustable at all. You have to decide upfront at compile time exactly how much memory you want to allocate, which might be it's not going to be the perfect amount, right? It's going to be either too much or too little. Too little means a crash, too much means a waste, right? And also, using this stuff was the biggest issue for me. Like, you know, check this out. I want to store the player transform. Let me just call memory.transforms.request from block 1. Like, what? Like, you know what I mean? As opposed to what? Like, what is player transform? It's an auto. That's a memory request. And then you have to be like player transform.memory position, right? Like, so transforms is a memory block of transform, which contains these things, right? So what, like, the alternative will kind of be like, you know, where's sending? This.
Yeah. So, okay. So.
Control Shift?
No, just Shift and there.
Okay. and then you just do transform dot position equals, I guess my point is that like, you've gone from this to this, which in my mind is like that's crazy.
Yeah.
You've made life so much harder for yourself. Like, and again, like, yes, it might be faster on the CPU side of things, which is great. I'm all for that. But what I'm saying is that your goal should be, I want it to be like this. Now, you're not going to be able to get it perfectly like this, and this is on the stack as well. But there's no reason why you can't make it not this specific.
Yeah.
Right? Like, you need to find a better way to make this API still kind of retain the usability and how intuitive it is, right? To kind of be as closely as possible to, I guess, like either the base C++ or just like a good API, right? So your goal is kind of to make this transition from, let's just say, worst performance. I mean, this is on the stacks. This is actually ideal, but let's just say this was on the heap, right? From kind of worst performance to better performance, but you're trying to make that transition as frictionless as possible. That's the key word, frictionless. You want it to be smooth.
Yeah. With something like the memory allocation strategy here, I mean, first of all, they did leave a comment saying they know it's not good and that it is problematic for all the reasons listed previously.
But this is a job interview as far as I'm concerned.
Exactly. It's just too verbose, first of all, to actually like use the API. You don't want to have to go through all of these hoops just to get a new transform. What I would preferably want is to be able to do just a stack allocated transform, set all my data and all of that. Possibly store that in some kind of component or on an entity. And then what you could do is you could have essentially a pre-allocated buffer in, say, your rendering system, because your renderer needs to know the transforms. And as you go through and you submit meshes and entities for rendering, you just put all of the transforms into that buffer starting at 0. And once you've done that, you can go ahead and render everything at the correct positions and all of that. And yes, that does result in a copy operation, but so does this. These are all copy assignments. But yeah, like the way I probably would have done this particular like allocation strategy might have been through something like a lazy allocator that just grows as needed, preferably not linearly by just incrementing by 1. Instead, it might do what standard vector does, which is I believe grows by 50%. Because that way
50% I think in MSVC and 2 times everywhere else.
Yeah. And like that way you still get that resizability, but you won't grow so much that you end up using a lot of unnecessary memory. Or at least it will take you quite a long time to get to that point.
But this doesn't grow at all, does it?
No.
This is just from a fixed thing, but you can just see the amount of items, and obviously the amount of transforms that there are here have been reserved to be max transforms, which is 1,000.
Yeah.
And then I guess all you're saying here is that I'd like 1, please.
Yeah.
And you get, I guess, basically a pointer, a wrapped pointer, into that 1 transform, which you can then use.
Yeah. Another problem I just realized with this is there's nothing preventing you from writing outside of this. It's like, sure, I'm requesting 1, but I could easily just end up, writing way outside of the memory.
Yeah, because if you change the 1 to a 2, then suddenly you can, because obviously you could just, another way to write this would be, right? So that's identical to what you had before, but obviously you only have 1. And if you suddenly change it to 2, then obviously array index 1 is now valid as well.
Yeah.
And so I guess,
But I think the way it actually does it is, if we take a look in here, it just sets it to item index into block, which means that if I just say here I request 3, the thing is the pointer is obviously pointing to contiguous memory.
Yeah.
So what's to stop me from, this could be done accidentally if you're doing it, say, in a loop. I could still end up writing into index 10.
Yeah.
And this is valid in terms of the compiler.
Fine. No, but it'll also be valid in runtime until you end up overriding that because the allocator thinks that's a free block of memory. Is there any kind of freeing By
I
the
didn't
way.
see anything.
Yeah, this is just you can't reuse memory here either. Yeah, so that's obviously not good. Nothing you do can be transient. Everything is permanent.
Yeah.
And also, I was just thinking about this while you were talking. Is that like obviously like you're writing into player transform. This is what you're dealing with. So you're not dealing with transforms.
Yeah.
You're dealing with memory requests of transforms. Which means that when you actually want to use it for something, such as like, hey, here's the player entity. Player entity just has an index, and that index is the index of like the memory request.
Yeah.
And then you create like a render entity from that. And then I guess that transform index, like it's just, I feel like it's adding an extra level of indirection and complexity to everywhere because you can't just pass objects or whatever around. You end up passing some kind of memory request indices, which, so I'm not a big fan of that either. Yeah. Especially because it doesn't, like, this literally adds nothing. These systems are fine, I feel, as long as they are abstracted away.
Yeah.
Because that really should be the goal. When they're at the foreground, then they make everything a lot harder.
Yeah, and, like, that kind of goes back to, like, what I was saying with renderer having, like, a transform buffer. That's, first of all, contained inside the renderer itself, so you don't have to interact with that directly as the user. And so what you just end up doing is saying, hey, I want to submit transform to the renderer, and this is the transform I want to submit. And if you really don't want to do a copy here, pass it by reference. You should probably pass it by reference because it's a transform. It's not small. And then that could be stored internally in a buffer in the renderer, which can then be used to draw entities at that transform.
So I don't know, there's lots of other stuff we could talk about, but I think that we're probably going to end it here. Hopefully those 3 points were kind of helpful, I guess. We decided to kind of pick a few specific points and expand on them rather than actually go through every line of code just because that's a little bit unmanageable. But thank you guys for watching. Hope you enjoyed the video.
Yeah, if you did, don't forget to hit the like button.
If you want me to review your code, then send it into chernoreview@gmail.com. There'll be some instructions in the description below. And finally, brilliant.org/thecherno. Check it out. I'll see you guys next time. Goodbye.